This Week in Radio Tech, episode 263 is brought to you by Lavo and the CrystalClear Virtual Radio Console. CrystalClear is the console with a multi-touch touchscreen interface. By the new Omnia Vocco 8, 8-channel mic preamp and voice processor with dominated technology. And by Axia and the new Axia Fusion AOIP audio console. The radio data system, RDS, has been on air in the U.S. since the mid-1980s. Good for what it does, identifying FM stations and providing call letters and basic program info. What if we could double or triple the data rate, allowing more text, graphics, and even supporting return data via IP or SMS? iHeart Media Senior Operations Engineer Alan Jurison joins Chris Tobin and Kirk Harnack to find out about RDS2. Hey, welcome into This Week in Radio Tech. I'm Kirk Harnack, your host. This is the show where we talk about radio technology. Sometimes we talk about towers and light bulbs and antennas and coax and pops and cracks and RF fire. And sometimes we talk about, keyboards and IT technology and, how you make radio stations run with that and things like that. It varies a lot because there's a lot of stuff between the microphone and the light bulb at the top of the tower, and streaming too. So that's what we talk about here. Thanks for joining us on This Week in Radio Tech. We got three great sponsors. We'll get to them as we roll along. And let's bring in our usual co-host. Usual because he's not an unusual guy. It's Chris Tobin from, you in Manhattan, Chris?
Yes. Today it's Manhattan. As I was saying earlier before the start of the show, I'm flying down to the NHL draft to do a broadcast on Saturday, so I'm getting packed and ready to go.
Where does that go on at?
Fort Lauderdale.
Wait, the National Hockey League has their draft in Fort Lauderdale?
Yes. I know.
I'm not a hockey fan. I'm not
sport itself. It's just about the venue and what people get to do.
Okay. Yeah, I guess so. I'm not much of any sports fan, but it just doesn't seem right to me. They ought to have that in Winnipeg, shouldn't they?
Right. Exactly. Calgary.
Yeah. I don't know.
Yeah.
Well,
but,
wow.
Hey,
what if we had a draft for broadcast engineers? What would that be like?
A lot of crickets.
We'd probably have to conduct it from Madison, Wisconsin.
Yes, exactly.
Yeah, that'd be a good place. Hey, folks, welcome in our show. On the show, we're going to talk about RDS and this new standard called RDS2. It multiplies the RDS data rate by at least a factor of three times more data through RDS. Is that interesting? Is that a yawner? Or do we already have other technologies that kind of make this unnecessary? Why is it important in some parts of the world and not important in other parts of the world, or it may not be important? Alan Jurison is going to join us about halfway through the show to talk to us about this RDS2 standard and what it might be good for, how we might use it in the U.S. and how other countries will be using it. So let's get into that. We also have a couple other interesting subjects to chat about, and I have a cool piece of equipment right here in my rack to show you. That's one of the sponsors. We'll get to that in just a minute. Hey, let's get to our first sponsor, because without sponsors, this show just doesn't work. We've got to have it to, make the money to buy microphones and distribute video and audio everywhere. So we appreciate GFQ Network and TWiRT working together to bring all this to you. And you can help out by not only listening to and watching the ads, but, hey, make some inquiries. Find out about the stuff we're talking about, because it's all useful stuff. It's stuff that I've either used or fully endorsed. Well, let's check it out. The folks at Lavo, they are famous for making huge audio consoles, the kinds that radio stations don't really need. But they also make some smaller consoles. And the latest console is a virtual mixing console. It's the CrystalClear audio console. Now, it uses a time-proven DSP engine that goes into a rack. It's just a one-rack unit box. And on the back of it, it's got all your normal, inputs and outputs that you might need to run a studio. So it's got some mic inputs, some line-level stereo analog inputs, some line-level stereo analog outputs. It has some AES inputs and AES outputs for direct digital connections to CD players or whatever else you might have that has AES digital ins and outs. And then it also has a network connection that is good for Ravenna, and it's compatible with AES 67. So it's connecting to all kinds of other gear that is also AES-67 compatible and also Ravenna compatible. Ravenna is an AOIP standard that's been pushed, promulgated, and assisted by the folks at Lavo. They have their own independent organization that handles the Ravenna standard. And Ravenna is already largely compliant with AES-67. So it just plugs right into that as well. Now, back to the console. Because it's a console that is run, well, the DSP engine can be run by a hardware console. They have that. It's called their Crystal console. But they also have the CrystalClear. And this is actually an app that runs on a PC. Now, it's an app that basically kind of takes over the PC. It takes over the whole screen, and so you really don't see the underlying operating system, even though it's there. And the app is this, it looks like a console. And because it's running on a multi-touch touchscreen monitor, you can just touch the faders, move them up and down. They respond beautifully. You can touch the option buttons. They pop instantly do what they're supposed to do. On and off buttons, mute, preview or cue button, an options button that pops up options for that function for that fader, whether it's a microphone fader or maybe a telephone hybrid or a CD player or an automation system. It just gives you the options that you need. Plus, there's faders for headphone volume and for speaker volume as well for the in-studio monitors. The console is set up with 2 program buses and also a recording bus, and that makes it really convenient to do offline recording while the console is still on the air if you want to do that. It has beautiful peak program meters. It has the availability of 2 power supplies in the DSP part. So you can have redundant power, maybe one of them on shore power, the other one connected to backup UPS power. And so if the shore power dies, you're still on the air. You still have excellent 24/7 uninterrupted power to all the electronics in the DSP engine. It also has some GPO tallies, so that if you need to turn on a tally light or make some other kind of indication or start a reel-to-reel recorder, if you have one of those, give an indication for something to start, you can do that with the GPOs that are built into the DSP engine. Hey, there's a video where Mike Dosh, who's now head of the virtual radio projects at Lavo, there's a video where he is demonstrating how this console works. And you really can't appreciate it until you touch it yourself, but Mike will give you a really good feel for how this console works. So go to Lavo, Lawo.com, Lavo.com, and look for the radio products, and then look for the CrystalClear audio console and give it a try. Look at the video, play with it. If this kind of tech appeals to you, and it very well might, easy to deploy, fun to use, then check it out. Lavo.com. Thanks for sponsoring This Week in Radio Tech. All right, Chris, this is one of those shows where you and I get to chat between ourselves here for the first little bit. And to get things started, I understand you have brought a show and tell item that is just really cool. You were showing this before we actually started recording. What you got?
Yes, I did. It's a mason jar single frequency FM radio. Let me put the microphone here to sort of make this work, hopefully. So we do this. Raise the antenna. Music. It's a jazz station, WBGO. And if you want to take it out to change the batteries, you remove the threaded cover. There you have it. 2 AA batteries, 3 volts total. Very cool little guy.
It has a small speaker in the top. Does the mason jar add anything to the acoustic
Actually,
qualities?
it does add a little depth. Difficult to demonstrate here, but if you take it off and place it in, you do hear a little bit. So there is some resonance.
Yeah.
And it's made by 2 gentlemen, one who enjoys doing audio and design stuff, and another gentleman who's a mechanical tinkerer. Both of them are in Brooklyn, and the name of the company, the product, is called The Public Radio. The Public Radio.
Now, with being a single frequency radio, it's pre-tuned, and I guess the consumer can't really retune it, or not easily.
No, there's no retuning on the fly. No, this is just basically it's a gimmick. It's a tchotchke or a premium for some stations that would like to just promote their radio station. I think the reason it's called the public radio is because for public stations, their audience tends to be very unique and don't mind having a single frequency radio of their favorite station.
Yeah.
So that's so it makes sense, because this particular type of premium single frequency radio is not uncommon. They've been around for many years, and commercial broadcasters have used them on many occasions and things of that sort, but never took off because most commercial listeners like to tune around the dial.
So does that's a great idea, and even commercial stations have used this idea back in the 80s or maybe the 90s. The Radio Advertising Bureau, or maybe it was the NAB, came up with a plastic radio that said "radio" is a plastic molded word, radio, and you could buy them. Radio stations could buy them as a single tuned, a fixed tune device, tuned to their station, of course, and give them out as prizes or tchotchke, as you said. Yeah. So
yes. Bloomberg Radio here in New York City many years ago in the late 90s, was it? Yeah, I guess it was late 90s or early 2000s. They did the single radio. It was a little rectangular black radio, so the word Bloomberg 1130, which is the frequency of the station, and it was single frequency. Even though it had a dial on it, no matter what you turned it to, it was always WDBR 1130 AM. It's sort of like a Henry Ford car. You can have any color you'd like as long as it's black. It was a black little radio.
That jar there. Now there are two competing brands of canning jars. One is Mason and one is Ball. There may be others, but those are the two big ones.
There are a couple of others. Yes, there are. This is a Ball.
Oh, it is.
This is a Ball. Oh, yes. It says it right here on the glass.
Yep.
It's a Ball, and it says the word Mason on one side, Ball on the other, registered trademark, and it's 250 milliliters. So I guess if you want to get creative, you could find
it says both Mason and Ball?
Yes, it has the Ball logo, because I have a couple of Ball Mason jars that a friend of mine makes a nice, very nice Italian sauce for pasta, and then it says the word Mason. Yeah, I don't know if you could see it. Hey, there
maybe
you go. Yeah, you probably
maybe I'm misinformed, or maybe one company bought the other.
Well, the original jar was made Mason. In fact, the Mason company was started by a tinsmith in New York back in the 1800s.
Okay.
So since then, it's just by default become called the Mason jar. So I think they put the word Mason on it just as a historical thing. But the companies that do make them, there's Ball, Kendrick, and there's like 2 or 3 others, about 6 of them that do it.
Okay.
But yeah, it's a pretty cool, little nifty little guy.
My mother-in-law's last name is Ball, and so she does canning at home, and so she has to get jars that say Ball. She won't use any other jars.
Yeah, the tinsmith's name is John Mason. Was first to patent a standard-sized preserving jar in the U.S. in 1858. Hence, the American term Mason jar was coined.
There you go.
There you go. There you have it.
I guess you could put that in a larger jar. Maybe you could put a bigger battery. You could put one of those big 6-volt batteries down in there. You think that would fit?
Yeah, you could. Do a larger jar and get a different audio resonance, probably.
Yeah, it's a little lantern battery. What else was I going to ask about that thing? God, I can't remember now. But well, you could do all kinds of things with the inside there. You could make sand sculptures. You could have you could have a terrarium. Grow some plants.
Be interesting when you're playing the music and the ants probably go crazy.
Yeah. Oh yeah, an ant farm. There you go. Have an ant farm in there.
It's a living thing. But yeah, it's called the Public Radio. Check out the website. It's pretty cool. It's a Kickstarter, or I think they've finished the Kickstarter campaign, so it's $40 if you'd like to donate to getting one. It's pretty cool. It's nifty.
Cool. Well, but one thing it doesn't have on it is an RDS display.
Not at the moment, no. But since it's programmed, since it has a computer chip on it and it's software driven, I'm sure there might be a way in a later version to do RDS.
How about they have all these ways to use moving LEDs, like spinning or oscillating LEDs to spell out words. You've seen toys at
I've seen those,
Brookstone or other places that do things like that. Well, you could have a mason jar that has like a spinning LED projector inside, and you could take the RDS data and project it on the inside of the jar.
That'd be pretty cool.
Yeah.
That would be really cool.
Huh.
Mason jar display. I just think this is cool.
I hear a patent coming down the line. I shouldn't have said anything about this.
Let's see if we do this way. Yeah. So that's the full radio, the antenna extended. So that's pretty cool. And it's an aluminum knob too. It's not even plastic. I mean, this is metal. This little knob here.
Huh.
So yeah, it's a Mylar speaker, so it actually has some response. So pretty cool.
Not sure what we're listening to.
It's jazz music from
Oh,
WBGO.
okay. Gotcha.
At this hour, I think it's the blues. The 2-watt speaker, 4 ohms, and it uses rocket alkaline batteries. No mercury, no cadmium. So.
When you first showed me that, well, what came to mind was, Martha and I were putting up radios the other day. We got a lot of them on the shelf to last us all through the winter.
Through the winter, it's a cat's whisker, you know. It's a
yeah.
Actually, it'd be interesting to make one for AM. Well, I'll have to talk to these guys. I'm curious. Yeah, public radio. It's thepubrad.io.
Ah, okay. Well, there you go. We'll put that link in the show notes. Let me jot that down. thepubrad.io.
Yeah, let me check what I did for the website. Yeah, I believe. Yeah, if you did a search, The Public Radio, it'll come up. But it's thepubrad.io. And it's pretty cool. As I said, it was two gentlemen in Brooklyn that build them. And their website has pictures of them showing them how they build it, what it looks like behind the scenes. It's pretty cool.
Wonder if I could hack that into being a HDTV receiver. You think? Probably not. All right. Hey, we do need to turn our attention to RDS. That's a subject with which you're pretty familiar, right?
Yeah. How many people still do RDS these days with HD radio coming about?
Well, I would, what I think happened. Well, to tell you what, let me roll back in time a bit here. RDS, what was the standard for RDS wasn't it first developed in Europe and then made its way over to the U.S. And back in the, I want to say back in the early to mid 80s, there was some push to get RDS technology on the air on stations across the U.S. And I want to say that there was a company, and I wish I remembered the name of who it was, that even provided RDS encoders to stations. I don't remember if I want to say they provided them to public stations. So a lot of public stations in the early to mid 80s got their hands on RDS encoders, and this at least put their call letters on. And of course, the company that provided them may have been providing some other data on there as well. So over the years, but at this time there were almost no RDS radios out there. So I had the following happen to me. I was the engineer at a rock station in Lexington, Kentucky, WKQQ. And at the time, it was owned by Village Communications out of North Carolina. And going through Radio World is probably what I was reading. And I saw these ads for RDS encoders. And they showed, that you could put call letters on there and a slogan. Now, back then, they weren't talking about dynamic data like title and artist. It was just program type, alternate frequency list if you had, ways of, other transmitters with the same programming, and your call letters, and then also some kind of unique code that would go out as well that your radio wouldn't display. But there were no radios to show you this at the time. So I went to our manager and I said, Keith, I think we ought to put this on the air. It doesn't cost us really anything in terms of volume. And someday, all the radios are going to have this. And his question, being the manager and the guy that wrote the checks, his question was, well, how many people would see our call letters now? And I said, well, honestly, probably none. He said, well, then forget about it. We're not going to do that. Well, fast forward now about 10, 12 years. And I'm no longer talking about Keith, the former manager there, but other managers that I ran into, they would go buy a new car. And the new car would have RDS in it. And they would scan up and down the dial, and all of a sudden, lo and behold, they'd notice that the local public radio stations, their call letters popped up. And guess what? Maybe another station on the dial, their call letters would pop up on the radio. They'd never seen this before in the late 80s, early 90s. And then they scanned our station, and there were no call letters. There was nothing. It just said, the tuning position. And the manager said, he'd come back to me right away and said, Kirk, what's going on? How come these other stations have our call letters on there and we don't? And of course, if I could, if I merged two stories together, I could say, well, Keith, maybe you remember that a few years ago I talked to you about this encoder box that we could buy and put on our station. Well, order one today. I want our call letters on there. So you see what the motivation was. As soon as the manager got a car that had a radio that would display this, then it became important at that moment. What do you have to say to that, Chris? Oh, muted. And while we're
sorry about that.
There you go. There you
There's
go.
noise in the background. I thought I'd keep it out.
Yeah.
Yes, early days. I remember the encoder was a green 1RU paneled encoder. That's all I can recall. I don't remember the name of it. But Ari Blaupunkt, the Blaupunkt folks in Germany, were introducing that system in the early days, and the car radios, and became popular. And I remember a few stations in the market I worked in were popping up with RDS, and people were fascinated by what it could do. Call letters and frequency.
Yes.
That was it.
Yeah.
However, in Europe at the time, they were using it for actually switching frequencies, and I think some traffic. I think that's what it was. The Ari Blaupunkt system, when it first introduced, I believe some traffic was being used for it. But what was annoying everybody was the fact that when it would come on, when a report would come on for RDS, they would turn off the FM and go right to the RDS channel.
Yeah.
Or the
Whether or
station
not
that
it was
was doing
affecting you. Yeah.
Right, exactly. So they're sort of using the European model in the States that didn't match. It was interesting. So I think gave people bad taste.
Now, let me speak to that alternate frequency thing for a minute, because in the U.S., that's something that would rarely be used. There are a few markets in the U.S. where you have a broadcaster decide they want to cover a given market, and so they can't buy a big Class B or a Class C for that market, so they'll buy several bedroom community Class A stations, 3,000 or 6,000 watts. Or maybe they'll get a bigger Class B, farther out of the market, 40, 50 miles away, and then they'll supplement that with a couple of nearby Class A's. In fact, our friend Chris Tarr used to engineer for a group like that. Actually, it wasn't Chris, it was somebody else. But in Chicago, there was a group like that had Class A's ringing Chicago, all around Chicago, and they put the same programming on them. Well, back in the late 80s? No, early 90s. I got to go to France and do some installations of audio processors. And in France, they, except for Paris, they typically don't have big towers and high-powered transmitters. Every town will have little transmitters. Typically, they'll be 1,000 watts to cover a town. Well, I was working with a group called Vibration, and they were out of the little town of Orléans, where we get our New Orleans from. And so they had transmitters in like a dozen towns, from Le Mans, where they have the Le Mans race, to a little town south of Paris called Pithiviers. And I don't remember all the other towns, but they had a dozen transmitters or more. And they distributed audio to these transmitters by 950 megahertz STL that were just hop. It was a big mess, and they eventually switched over to satellite. But anyway, each transmitter site had its own RDS encoder, and each transmitter site would transmit this AF, that alternate frequency list, so that a radio, an FM radio designed for this, would typically have two tuners. In fact, we drove around in a really nice car, and it had a beautiful Blaupunkt radio in it, and it had two FM tuners. One of them was tuned to the station you're listening to, and the other one was scanning around the alternate frequency list to see if there was a better signal. And if there was, then it would switch over to that better signal almost imperceptibly. And if you kept the modulation the same on all the stations, and the timing of your audio to them was about the same, it was great. It wasn't a single frequency network. These were just individual different frequency, like low power FMs like we would have, or translator style. Again, the transmitters were typically a kilowatt or less, with typically 1 or 2 or 3 bay antenna on top of a water tower in a town. So the coverage wasn't that great. But as you drive around, your radio would switch, and you could tell it though to stay with this same station, stay with Vibration. And it would always find you the best frequency available. In the U.S., we have almost no need for that, but man, it worked really, really well there. And I think that was their primary use of RDS at the time. Chris?
Oh yeah, it absolutely was. I remember when the technology came out, I was reading up on it. And I remember talking to a couple of European broadcasters about it and how they used it. And that's exactly, just as you explained it, that's exactly how they told it to me. And I was like, oh, wow. I wouldn't do much for us here, but okay. But it was interesting, and RDS unfortunately didn't get the push it should have received. And as always, broadcasters sort of stick with what they know and just hope for the best, and then things just move along. So RDS sort of fell by the wayside. But the RDS2 though, the new one coming out, might prove to be interesting for stations that have chosen not to do HD, but still want to do some type of metadata and do something that puts their station at least up with the others.
Or if they want to do data that for people, well, okay, any receivers that would pick this up would be newer than HD receivers, so that may not be a very strong argument. But none of my stations are doing HD. We don't feel like it's a strong thing for us right now in the rural areas where we live. So here, tell you what, Chris, let's review for a second for the members of our audience that don't know what RDS is, and just a brief overview of how it works. RDS is radio data system or radio data service, or one of those, and in the U.S. there's actually a slightly we have to be different, right? So there's a slightly different term. It's RBDS, Radio Broadcast Data Service, and it's got a few changes in the data fields to make that happen. But what it is slow speed data, just under 1200 baud, and it's really slow data, but it is able to be broadcast along with an FM signal. It's actually a little carrier, a little frequency shift keyed carrier that resides in the FM baseband above the stereo information. So it's not as high up as say an FM subcarrier was. Remember those? I think not so many folks are using those anymore, but we used to have audio subcarriers of low audio quality. Typically, it would be mono, typically at 67 kilohertz on the FM baseband. And another one was possible at 92 kilohertz. Some stations use this for data to get from the transmitter side back to the studio. Others might use it for talkback, so they could actually in real time have a channel to talk back to remote sites. We use that. Some stations used it to spy on the microphone in the control room so that the manager could listen at home and see what was going on back before we had IP cameras. And other stations would use it for Muzak. That for a number of decades, that's one way that Muzak was distributed to store audio. Muzak would get their audio to the FM radio station, and then it would be transmitted over the 67 kilohertz subcarrier. Again, it was low quality, only about 5 or 6 kilohertz of audio bandwidth, and the signal-to-noise ratio wasn't that great. But hey, it worked okay for its purpose. Well, the RDS carrier is at 57 kilohertz, and it has a set regimen of data fields where you can transmit your call letters. Hey, there was a big paging network back in the 90s called Q paging. This was before cell phones really came into popularity. I guess the 80s and 90s. Q paging was a nationwide paging service. And so you'd have this pager. They were kind of big and clunky, but these pagers would listen to FM stations. They would look for FM stations that had the Q paging signal on it. And then it was really popular among truckers because Q paging built a network of stations. They paid stations to carry their data. And so Q paging would put a satellite dish and a data receiver at the transmitter side typically, and then insert their slow speed data, and they would provide you with an RDS encoder, and they would go ahead and put your call letters on it, and they would transmit their data to pagers. So that was a very utilitarian use. It was a good model, and it worked, until economically you just might as well get a cell phone, and remember when cell phones were first out, roaming was complicated, and so there wasn't instant nationwide roaming. Now there is, so that it negated the need for Q paging so much. So I was getting to explaining this carrier, and maybe Chris, you can expound on this a bit. But at 57 kilohertz, it's a frequency shift keyed carrier. It carries ones and zeros. I'm sure there's some kind of error correction that's built into it to try to get accurate data through. And have I described it well enough, or is there some other aspect you want to add to this?
Oh no, that's correct. Yeah, it's 1200 baud, I think, roughly. But I think after all the overhead and everything else it does, it's somewhere around 700 kilobits or 600.
Yeah.
I forget the exact throughput. It's also the third harmonic of 19 kilohertz, so you can actually pilot phase or pilot lock the carrier to your FM signal, so you can reduce the multipath potential of an out of sync subcarrier with the main band. So 19 kilohertz times 3 is 57 kilohertz. One of the reasons why they chose 57 kilohertz.
Yeah.
So those of us who have done SCA transmissions know that 67 and 92, depending on how stable those carriers are, and how much injection level you use could sometimes create havoc on your signal. If you had a multiple bay antenna, then multipath may have been a little bit annoying in some parts of your coverage area.
Yeah, a lot of the problem there was you could create audible birdies on the air, the little whistling sounds, and that was especially came about if you had non-linearities in your baseband. So if your exciter or if your STL was carrying the 67 or 92 kilohertz subcarriers or 57, if there were non-linearities there, then you'd end up with distortion products up and down the baseband at places that could be decoded by FM stereo as little whistling sounds that could go on. So the better your transmitter was tuned, and the more wideband it was, and the less distortion or IM distortion products that there were, then the cleaner everything would be. Luckily, and I think in my experience was in later years, as transmitters became more and more wideband, and we got more solid state transmitters and just better designed tube cavities, I had less and less problems with birdies or any non-linearities as time went on. Did you find the same thing to be true?
Yeah, that's true. There were a couple of stations here in the city that had that issue with the birdie back in the heydays of SCA rentals. But as time went on and exciters became more stable, more accurate, and the ability to filter out out-of-band signals or minimize their impact, yeah, the birdies disappeared. But they were big time. I remember back in the 80s, you could always tell a station that was renting out their subcarriers or using the subcarriers.
And the amount of subcarrier injection, it used to be that you had to reduce your main modulation by half of what your subcarrier injection was up to some point. I won't get into all that. But I will say that, running a subcarrier, whether it was RDS or a 67 or 92 kilohertz subcarrier, did cost you a little bit in terms of loudness. Well, maybe it didn't cost everybody in terms of loudness, but it was supposed to cost you a little bit, so you kind of stay within the bandwidth mask. But now 57 kilohertz subcarrier, the injection level there, oftentimes you get by with 2, 3, 4, 5% injection. Now, some
I
people
think 4% was what they. I think 4% is what they usually recommended. A lot of folks I know used to go less, but I think the standard, the protocol required 4% to be optimal.
Now, the RDS encoders, I mentioned earlier that, hey, maybe they used to be $1,000, and I'm sure you could spend more on one. Now, they've gotten this down to just 2 or 3 chips and a cheap board. You can buy an RDS generator now from, there's a company called Pira, and I believe that they're in the Czech Republic, and they sell kits in various levels of assemblage. You can buy them a finished one. You can buy a kit with parts, just the circuit board if you want. Bottom line is, if you want to put RDS on there, you can do it for $100, maybe less. You can also, and this is something that I'm not sure which audio processor manufacturers have done this yet. I believe that Leif Clayson at Omnia has done this, and the other guys at Omnia have intentions of doing this if it's not already done. You can do this all in software. You can do RDS encoding in software just as you're doing stereo generation in software. So you're going to find more FM processors will have RDS encoding just built into them. You feed them data. You program the fixed data, like your call letters, and then you feed them the dynamic data, like artist and title, either via IP or still via serial data if you want to. And the RDS encoder in the audio processor can just go ahead and get this done. So there's ways to get this done. I even think there's a couple of exciters on the market, FM exciters, that have built-in stereo encoders, and they've gone ahead and built in RDS encoders in there as well. So the point is, it doesn't have to cost you $1,000 or $2,000 now. It doesn't even have to cost you $700 or $800. You can do it for substantially less, or you can get it built into your audio processor. Chris, any thoughts on there before we move on?
No, that makes sense. I mean, if I was a station owner today, I would definitely do RDS just to be relevant to the rest of the marketplace, because nowadays in cars, with the current RDS protocol, call letters and frequency appear at least put you up there with the others that are doing a more dynamic metadata approach, and do the song title too. It's not that difficult. Go for it, make it happen, and stay relevant. Otherwise, you'll just be in trouble. But RDS2, I don't know. I'm not sure how that's going to fare and where that's going to go. I mean, unless you've heard something otherwise.
Well, yeah, that's what Alan talked about in our interview. So we're going to get to the interview here in just a moment. I want to remind our viewers and listeners, that you're watching This Week in Radio Tech. It's episode 263. Chris Tobin is here as usual. I'm Kirk Harnack, and we've been just dishing a bit on the pub radio. That was interesting. We'll have a link to that in the show notes, and on the fundamentals of RDS, that it's a data technology. It can get injected into the FM baseband. It's ignored by radios that don't have to worry about RDS. But every car radio on the road nowadays, with almost no exception, has RDS built into it. So you can see call letters. You can have program types. So if you want to just scan the dial and only stop on rock radio stations, many radios, you can do that. Tell it PTY, which is program type, and tell it to scan, and bam, you can do that. So it's good for some very basic data transmission objectives. Now, RDS2, we're talking about that with Alan Jurison when we come back from our break. Hey, I got something to show you here. This is cool. Couldn't wait. Let me pull this camera down here. You are looking at, let me see if I can point there. You're looking at an Omnia Vocco 8. That's it right there. And if you can look at the upper left-hand audio processor, that's actually connected to my microphone. So there you go. But what's available in the Vocco 8 in terms of audio processing goes far beyond what you see on the little screen here. This is just a monitoring screen and lets you change presets. It lets you change whole shows. If you've got a morning show with 5 people in there and a midday show maybe with 2 people, this mic processor is just amazing. What it is, the Vocco 8 is a mic processor, and sorry about the camera there. I'm going to bring up something on my screen here. I'm not going to share the screen with you, but what I'm going to do is turn the camera around to show you this. This is the control panel for the Vocco 8. And all those controls, that's for one mic. It's just amazing. I've been playing with this Vocco 8 now for about 3 days. Oh my goodness. The possibilities for mic processing in this thing are just amazing. I have come up with a preset for my voice that, I mean, it's if it's not the voice of God, it's the next thing. It's just amazing. And of course, you can set it for very natural treatment. You can set it to get rid of some room noise. I couldn't possibly go through all the settings and features of the Vocco 8. But one thing I want you to know about is that it has a feature in it called Dominate It. Dominate It. And what that does is you've got a multi-mic morning show, but you've got one guy who needs to be able to take control of the conversation. When he talks, that's it. He takes control, or she. Well, you set up one of the microphones in a group. So you run all the mics into the Vocco 8, and you set up one mic to be the dominant microphone, and how much domination you want that mic to have. When that person talks, it doesn't cut everybody else off, but it does push them down by how much you tell it to, and it gives that person absolute authority and priority on speaking. Now, of course, you can do that with your faders on the console, but you may have to grab 5 faders. The Vocco 8 does that for you automatically. It is just amazing. And by the way, on the Vocco 8, you can run more than one show. So you can be doing, if there's 8 processors in it, you can be processing 5 mics for Studio A and 3 mics for Studio B. And you can change, wholesale shows if you want to. You can adjust processing so nicely. It's got some great displays right here. For example, there's the de-esser right there. I don't know if you can, whoops, let's see if I can get down there. Where's it at? Oh, it was up there. There you go. There's the de-esser. I don't know if you can see that or not, but there's the green line. If I make some hiss noises, you can see the green line. There's the parametric EQ right down there. You can make it sound just really awesome. I got to tell you, I'm so excited about this audio processor, this mic processor. And to give you just a quick feel for, okay, so Kirk, what do the inputs and outputs look like? How does that work? It is, as you buy it, it has 8 mic preamps in it. There's a base price for it. It ain't cheap, but for what you get, it's amazing. The base price includes a couple of mic processing, and then you can pay more per license, more processors. But it comes with 8 mic preamps, and these are awesome mic preamps. They use the very best Burr Brown A to D converter chips meant for mics that are available. They are so clean. I mean, the self noise floor is like 128 dB down. Simply amazing. I could go on and on, but I only have a certain amount of time. The Vocco 8, go to the Omnia website, omniaaudio.com, or of course you go to telosalliance.com, click on Omnia, and then look for the Vocco 8, VOCO, the Vocco 8. 8 mic processors or less. You don't have to pay for all 8 if you don't really need all 8. Inputs, mic inputs, live wire inputs, or AES inputs. If you're already, preamping some other way, fine, you can do that. If you want to process, a line level source, no problem. If you want to process some live wire sources or AES 67 or Ravenna sources, all that's built in. Just amazing. All right. Thanks, Omnia, and thanks, Vocco 8. And thanks to the designer of the Vocco 8, fantastic designer named Vincent Defraudin. He is just an amazing guy. So hopefully we'll have Vincent on the show one time to describe just the things that make mic processing work so well. All right, Chris, what do you think about this Vocco 8? Sounds pretty cool.
That's really cool. The only thing is the dominating feature. When I worked with the Imus in the morning show, his approach to it was basically we gave him the on-off control of all the microphones at the table in the studio, and he just turned everybody off as he wanted to be the dominant voice.
Yeah, there you go.
He did it the old school way. He just basically said, "Yeah, what? I don't like what you're saying." Click. And he would just talk. And if you listen to some of the old air checks, you could hear it like people be mid-sentence.
They're already using this technology at a radio station in France, or several actually. And one of the things that happens with Dominated is, let's say everybody's yapping all at once. There's a cacophony of voices, and the main person comes on and says, "Okay, here's where we're going to go with this conversation." It cuts the other people down. They stop hearing themselves in the headphones, or at least not very well, so they naturally shut up. They don't keep talking.
Oh, yeah, that's great.
They just naturally, okay, Big Bob's talking now, so I better be quiet. Just cool. We're going to have some more on this processor. At first I was, okay, cool, fine, 8 processors, same box. All this afternoon I've been running my mic through it, and it's just amazing. Amazing.
Nice.
All right. Let's see. We have this interview with Alan Jurison, and if the studio is ready to roll the tape, we're going to roll the tape with Alan Jurison. Hey, Chris, don't leave, because we're going to chat for a minute about what he says. About
I'll be back.
Yeah, 50-minute interview. So let her roll. Hey, it's Kirk Harnack interviewing Alan Jurison. Now, Alan, welcome in. Glad you're here.
Hey, thanks. Thanks for having me on.
By the way, in our test, your video wasn't so clear, and now it's just cleared up. So I guess we got a better connection, or you hit your webcam upside the head or something.
Or I upgraded the webcam between...
You do, during the show, yeah. So, Alan, what got me interested in talking with you, and I see your posts here and there, and you and I really haven't had a chance to talk much otherwise, so I'm glad to meet you this way. But I saw this article in Radio World, which is a great source of news and topics for This Week in Radio Tech. But I saw your article you wrote about this new change to RDS, the radio data system, called RDS2. I think most of our viewers and listeners probably know what RDS is. It's that slow speed data that gives you call letters, program type, artist and title if you want to do that. And in the U.S., that seems to be about all that we use it for. Maybe a paid commercial message here and there. Hey, in Europe, they use it for alternate frequency. You can drive all around France and keep listening to the same station on different frequencies almost without interruption. But we don't use that here. But so talk to us a little bit about this new RDS2 and what you're seeing in it that's different or maybe an advantage for U.S. radio stations, if any.
Yeah. Well, so the problem, as you've kind of imagined, is RDS, the existing RDS that we have all grown to love and know pretty well in the United States here. It was all designed in the 80s and implemented in Europe in the 90s, and then the U.S. was kind of slow to start with it. But in the early 2000s, a lot of stations started adding RDS encoders to their stations. And, it was a basic text service. You can send title and artist through a couple different fields, program format types, those kind of things. And, for most broadcasters, that's what they've used it for. Now, in Europe, they're doing some great things with some alternate frequency switching, as you mentioned. But also in Europe and in the United States, there are networks of RDS TMC, or traffic message channel stations, that actually take some of that portion of the bandwidth that you would see that you would use from the title and artist fields. They get thrown into binary data that can be sent to navigation receivers. And so it eats up quite a bit of the RDS payload, which takes away from how well title and artist can work and those kind of things. And so, of course, all that stuff and all that amount of data is kind of frozen in time from this standard they developed in the 80s. And the amount of useful information, it's only it's slightly under 1200 BPS. It's like 1187 or something like that. But by the time you pare down all the redundant information, there's only about 400 or 500K a second of usable data in the RDS1 or existing RDS stream. So, and especially in the international markets, they've wanted to increase the capacity of it so they can increase the level of messaging. Navigation systems are a lot more sophisticated than they once were. Than the first iteration of GPS receivers and things like that. You look at all the vehicles now with embedded navigation. They want to include traffic information in it, and in countries where RDS is the main payload of getting traffic through broadcast to a vehicle, RDS TMC is really very limited, bandwidth limited. So a lot of this has come from the European members of the RDS forum. And what they're proposing to do is add a new RDS specification, RDS2, that would be available for new receivers that significantly increases the amount of bandwidth available to those receivers, so that they can do things like more things with title and artist, but also get that payload for example, RDS TMC, so they can get a lot more information sent through for the navigation devices through RDS.
Okay, so how might that apply itself to the U.S.? You said it gives you more data. I guess I should ask, how does it give you more data? And is this at all backwards compatible with RDS regular RDS receivers?
Yeah. So kind of the high level view is the RDS2 specification essentially adds 3 new subcarriers, data subcarriers.
Okay.
So RDS1, which a lot of us have familiarity with, it runs at 57 kilohertz. There are and essentially they're saying that the RDS2 specification will basically be backwards compatible to RDS1. They're going to leave RDS, the existing subcarrier that we already use, pretty much alone, so that all the legacy devices just continue to work with it. And there's no major changes there. But where they're making the changes are they're adding 3 new subcarriers, which RDS1 receivers will, assumably, ignore it, because they've always ignored SCAs. Like, we've had 67 kilohertz, analog SCAs that we've used for audio or other data purposes. Yeah. The receivers, don't see that. So in this new spectrum, the spectrum, where the 67 kilohertz subcarrier goes all the way up to, I'd have to look at the actual numbers, but it's, between like 66 kilohertz and 76 kilohertz or so, they add 3 new data subcarriers to significantly increase the data capacity of RDS. So RDS2 receivers would really look at those 3 new subcarriers, maybe some information from the RDS1 subcarrier, so maybe up to 4 subcarriers of information, whereas RDS1 receivers are the existing ones that we all know that are in all the cars that we drive today and things like that, would just continue to look at the 57 kilohertz subcarrier.
Okay, well that makes perfect sense. Adding more subcarriers gives you more available bandwidth. For especially here, we found through some of my work with the NRSC, the use of 67 kilohertz subcarriers are still out there. There's still stations that use them for various needs, but they're nowhere near where they used to be in popularity and usage as they were maybe even 10 years ago. A lot of stations used to use it for an IFB for remotes, or they used to use it for used to lease it out for other data services. Like Microsoft was doing something for a while, or they used to lease things that, those types of carriers for, foreign language broadcasters. Yeah,
or
niche broadcasters, maybe churches.
Yeah, and also, the radio reading services
Sure.
for visually impaired people who would like to get latest news. But technology's changed and radio's changed so much in the last 10, 15 years that the needs for those types of services carried over to traditional analog, FM, SCA have decreased. So that leaves that bandwidth open, and I think for most stations that aren't running in SCA, that could be something that they look into, eventually adding if the standard is adopted by receiver manufacturers.
Gotcha. So from the point of view of a U.S. consumer with an RDS radio in their car, they're not really going to see any change. But if you have a navigation system that can use RDS delivered,
the big difference is in navigation systems would be it. But the other thing is I mean, it would improve, in theory, it would improve how quickly the title and the artist can be transmitted through. So when the song changes, it might arrive to the radio faster and maybe more in line of what you're used to seeing when you watch streaming audio. If you're streaming the audio over your phone or the internet through an app or a web page, usually you get the title and the artist immediately. With RDS, if you notice it as closely as some of us do, it does take a little bit of transmission delay to get from point A to point B, and because of the slow data rate. So RDS2 can perhaps solve that, since it's significantly faster, and help improve that user experience, and also make it more like HD radio does the same thing. As soon as you send that information, it immediately becomes active. It doesn't take very long for that data to for title and artist information to transmit. So that could help significantly with U.S. consumers. As far as from a traffic standpoint, I don't know, at least in the United States, how well that's going to be needed, because the two major traffic networks that send data over RDS TMC. There's two networks. You may have heard of the BTC, or Broadcast Traffic Consortium stations, and then of course iHeart Media, on which I'm employed with. We have a nationwide network of RDS stations. We also do our own RDS TMC based networks. These two different networks already offer navigation data to car receivers and things like that over RDS, but both networks are really already well beyond the transition, and all new devices that are coming out are actually using HD radio, the advanced application layer of data services through HD, which has significantly more bandwidth and error protection and things like that. So I think in the United States, I don't know if RDS TMC is really going to be the big driver for RDS 2.0. I think that's kind of already migrated to HD. So I don't know if necessarily, any major commercial interest. But RDS2 doesn't necessarily mean that we wouldn't be interested in it. As I said, it helped that title and artist display come up a lot more, sooner. It'll also probably help, possibly, and we'll have to see how it works, but possibly in edge of coverage areas where you have intermittent signal. If you're getting the title and artist more often, because it's a faster data rate, it might display, whereas with RDS1, you might have so many errors it can't recover from that. So it'll be interesting to see how that all pans out. There could be really interesting applications in emergency alerting, possibly, that could use it, since RDS has been used for RDS, the original one's been used through a couple different systems through emergency alerting. Yeah. Maybe that can grow through RDS2. So it's not to say that there aren't huge interests or huge needs for the United States, but some of the major commercial things, like navigation devices, are already migrated to HD. At least the new devices. We're still supporting legacy machines or cars. There really aren't new cars or devices that are coming out that are doing RDS TMC. It's all HD. Both for our network here at iHeart Media and also the BTC's network as well.
Yeah. Okay. Well, it does sound like a good use of application of technology where people aren't so much using 67 and 92 kilohertz for analog services. They got this bandwidth available, this upper baseband available to do something, and now there's a standard that lets them do that. Even though I guess in countries where you don't have HD radio, instead you've got other services, DAB. You'd be more inclined to have some uptake on this RDS2.
Yeah, that's why I think that the real drive for this is coming from Europe, for example, where they might not have the interest or bandwidth or desire or whatever the situation is over there, they may not be able to go to HD radio. So they might not have that as a kind of a tool to transmit it. So this allows stations in other countries, particularly where HD radio is not authorized, it allows them to offer title and artist and also some higher bandwidth data services, like an improvement to this RDS TMC. There's also something we haven't also talked about. There is, as part of the original RDS2 specification that they're working on, there's a basic station logo service as well. So you could send it's very small, it's about 4 KB file, but a very small station logo could be transmitted through RDS, which we can't do that today. And I think I think that would be very helpful, especially for stations that aren't doing HD radio or aren't doing, for example, the artist experience with title and artist and album art and station logos that way. It could be a way for maybe smaller markets in the United States to have some of those features that some of the big stations have in big markets that did HD, but without as much of a hard cost or investment to upgrade transmitters, et cetera.
I do wonder if receivers would end up being available in the U.S. that would make use of this. I own some stations in very small markets. We don't have any HD signals in any of the markets where our stations are in, and our stations don't do any HD either.
Right.
Of course, you mentioned earlier you're with iHeart Media as the senior ops engineer, so you are really hands-on with seeing, what can we do with this? How can we integrate this with other iHeart stuff? So I could see stations like ours easily turning on this RDS2 and putting interesting data on it, maybe textual weather, if receivers were available to do that, maybe text alerts, maybe commercial copy that goes along, with a message or a coupon or whatever. And I know we've talked about coupons for probably 20 years. That's a possibility in radio, and it never seems to happen very much. Certainly in the U.S., so much is geared toward HD radio where this is happening. I guess feeling left out again in the hinterlands of Mississippi.
Yeah, well, it's we'll see how it evolves. I mean, if especially in Europe, if it really catches on, just like RDS1 did, it'll eventually show up here. Especially nowadays, car manufacturers. I work a lot of some of my what I do with iHeart Media here. So I work with automotive manufacturers on their implementation of HD radio and our data services and things like that, and they're very world conscious. If they can make a product that works, everywhere without having to make modifications for, you need this one for the United States, and you need this one for Mexico, and you need this one for Europe, and that kind of stuff. They're working on globalization of their design, so it'd be really easy to port whatever they do. If they have RDS2, if they incorporate in their main design, eventually those radios will make it over here, because we do live in a global economy, and there's a lot of non-U.S. cars that are on our roadways and the other thing is even the U.S. cars, a lot of the designs of the receivers, they're global designs as well. The U.S. manufacturers are making cars, for Europe, so it's the exact same same thing. They might be focused mainly on what we think is focused on the United States, but when they're doing all their new radio designs and systems designs, they're really thinking in a global method. So if they add RDS 2.0 to their radios, it would eventually make its way over here whether we wanted to use it or not.
Gotcha.
The question is would they activate it? They do have some levels of those types of control. Do they turn on a certain feature or not in a particular market? But they have moved towards globalization.
So you've explained this very well. I think we got a good handle on it now. If engineers come across this or an opportunity, hey, now at least we know what RDS2 is. 3 additional data carriers that go in the upper baseband of FM, similar probably in I guess in modulation scheme and other things similar to the original RDS.
I haven't had a chance to be hands on with it, but the spectrum plots that I've seen. Of some of the tests that they've done in Europe, it looks identical to the RDS one carrier that we all know and love. And basically, what they're proposing is that there's 4 carriers. You inject them all at 2.5% apiece, so that gives you a 10% injection overall. But no carrier is more than 2.5% is kind of what they're discussing right now.
Gotcha.
So it'll be interesting to see how that progresses. In the United States, the NRSC is involved. They've reached out to us, and we kind of have a liaison relationship with them anyway. What we're trying to do is just make sure that, whatever guidelines and standards that are developed for Europe, that they'll be compliant and compatible here as well. We've done a real good job. A lot of people at the NRSC have been working very hard with the folks at the RDS forum to make sure there aren't many differences between RDS and the United States version in Europe. And we've done a lot of work of that in the last few years, and we're going to continue to work at that with the RDS2. So we're looking forward to, learning more about the concept. Remember, all of this is still in draft form, so don't look for going out to your vendors tomorrow and asking for an RDS encoder. But it's that supports it. But we're getting there, and I think the big upside in the United States will be, I think we're kind of in a wait and see approach to see how well it takes off in Europe and how well it gets embraced by particularly automotive OEM. We have, we saw how long it took to get HD radio in vehicles. It's been a 10+ year process with that. So is RDS2 going to be a similar thing or not? It depends on how well it gets embraced, particularly in Europe, I think, is what's really going to drive that.
So, Alan, behind you there are some very fancy-looking radios.
Oh, we got all sorts of fun stuff.
Is all that secret stuff, or can you give us any tour at all?
Well, there's just really not a lot. Not a lot that's secret back there. Let's see. Over here. You may have seen it at the NAB show in the Ubiquity booth, in the TWiRT booth. It's their their market area monitor, MAM, the MAM2, which Ubiquity was doing a really good demo of some monitoring they're doing. Of their HD radio signals in all the markets. They've actually issued a press release that so this is all public knowledge.
Yeah.
They're deploying a whole network of these, and we're doing some testing with them as well, just to see how well they perform and things like that. And then over here we have some HD radio receivers that receive some of our data services. Let's see, on the top one is just showing Artist Experience, one of our stations with the station logo, and below it is a head unit from a Toyota Tundra showing our HD radio, one of our HD radio simple traffic maps. So that's some of the stuff I have in my little lab here that I keep my eye on.
Nice. Hey, Alan, thank you so much for joining us and taking some time out and explaining this RDS2 and whether it's something to look at or just not worry about until it comes along. But I appreciate you taking some time, and hey, you're the guy who would know about it, being the senior ops engineer.
Yeah, well, we're
trying
real hard here to make sure that we look at all sorts of new ideas and learn how we can use them both internally, and when we can share our knowledge elsewhere, we do. And I think that's helpful for the whole industry. So thanks for having me on to describe what RDS2 is all about. Hopefully, it gets rid of some confusion.
Good deal. And if folks want to see a little bit more of this in print, there was an article in Radio World just in the last couple of weeks about this, and that's what tipped me off to it and asked Alan.
And I think you'll see more, as the coming months and years come on, as the NRSC looks at this in closer light. There'll be more of that. It's an interesting time. It's basically a brand new standard, and they just in this convention that they did a couple weeks ago out in Europe, they did the first demo of a real kind of prototype RDS encoder that supports this RDS 2.0 standard that they've been working up. So, and they had a prototype receiver. So it's really on the edge of development, but they're looking to hope to launch it relatively quickly soon. So we'll see how long it takes to make all that happen, and we're here to help along the way.
Great, Alan. Thanks again. Appreciate you joining us.
Great, thanks, Kirk.
Okay. And you're watching episode 263 of This Week in Radio Tech. That was Alan Jurison with iHeart Media. He's the Senior Operations Manager? Director? He's in charge of that. We'll be right back. Chris Tobin and I will have a final word after this word from Clark Novak at Axia.
Hi, I'm Clark Novak from Axia Audio, and I'm here to introduce you to the new Fusion AOIP mixing console, the newest modular AOIP console from Axia, the company that invented AOIP for broadcast in 2003. Let's take a quick look at some of the unique features found only in Fusion. In this video, we'll explain how Fusion optimizes your operator's workflow. How easily your board ops can communicate with others makes a big difference in how smoothly and professionally a show is produced. That's why Fusion has built-in communications capabilities, very sophisticated ones, that include talkback, back feeds, and even intercom capabilities to multiple locations, both inside and outside the studio. First, let's look at TalkBack. At the bottom of every fader strip, you'll find a key marked TalkBack. This is one way that Fusion helps automate your workflow and enhance communications. This is great for when your board op needs to give information to selected talent in the control room or another studio, or even remote talent sending audio over an ISDN, IP codec, or radio link. When the board operator pushes the TalkBack key on a fader assigned to the mic of a studio guest, he's instantly talking off-air to the headphone feed that's paired with that guest mic. And if that guest has an optional guest control panel, he can press his TalkBack key to talk back privately to the board op too. When the board op pushes TalkBack on a fader that has a remote codec loaded, he's instantly speaking to the remote talent via the codec's IFB. Neat, huh? Another area where Fusion eases workflow is the way it works with phones, an important part of many broadcast operations. Right next to the TalkBack keys at the bottom of every fader are keys labeled Set and Hold that let you place phone callers on hold or transfer them to a studio phone set right from the console if your phone system supports it. Or if you have a Telos multi-line phone system, you can take direct control of multiple callers and lines using the available Call Controller module. Using its controls and information displays, your board op can easily screen, queue, and air multiple callers without ever taking their hands or eyes off the console. Speaking of phones, let's talk about mix minus, or clean feed, N-1, whatever you like to call it. With Fusion, there's no fiddling with manual bus assignments to construct manual mix minuses. Phone callers automatically get a custom mix minus derived from the on-air mix. Doesn't matter if you have 2 callers on the air or 20. Each caller gets their very own custom mix minus without any effort from the operator aside from pushing the fader on button and without tying up one of the primary mixing buses. Of course, for special circumstances, you can manually build a custom mix minus from any program bus on the fly with just a couple of button presses. Finally, Fusion enables better whole plant communications with built-in intercom capability. Whether you have a big radio plant or a radio-TV combination, optional Fusion intercom modules let board ops use the board mics and preview speaker to quickly communicate with personnel in other places, like control rooms, editing booths, TOCs, or anywhere else. Fusion intercom modules come in 10-station and 20-station sizes. Frequently called stations can be pre-programmed for instant access. Other stations can be dialed directly. And here's something really special. Axia's IP intercom system provides real broadcast quality audio, not intercom audio. So the breaking news or vital information can be taken to air right from the intercom system without waiting for them to get to a studio. If it's on the intercom system, it's instantly available to air. No matter how complicated your workflow, Fusion has the power to help you detangle it for smoother, more error-free shows. Thanks for watching. We'll see you next time.
And thanks to Axia Audio for sponsoring this portion of This Week in Radio Tech. All right, Chris Tobin, you brought us the public radio in the mason jar. That was cool. We talked about RDS and heard from Alan Jurison on RDS2. Is there anything you'd like to leave us with? Any words of wisdom?
Words of wisdom? No, unfortunately, I don't have any words of wisdom today. Just the mason jar radio. And for a gentleman I know up north, north of the border, Wally Lennox, he knows what this is about. Check into this public radio. You'll find it very funny. It's fun. Give it a try. Other than that,
I know Wally too. He's a good guy.
Oh, okay. Yeah, he's a great guy. And I know he's a fan, and he tunes in, and when he's traveling across the country, he's doing stuff. He puts us in his iPod, and listens to past shows. So I'm just going to throw the shout out to Wally because he's a good guy, and everybody knows him. So it's no secret. And he should check this out because he loves little gadgets.
All right, good. Hey, thanks so much, Chris Tobin. And tell you what, folks, we're going to take a break next Thursday. We're going to play you a best of, give you a chance to catch up maybe on some older episodes that you haven't listened yet. Remember this episode where we explained RDS or a lot about it, probably a good reference episode, and we have a lot of good reference episodes early in our repertoire. So be sure to check those out. They're all available at thisweekinradiotech.com. Thanks to our sponsors, Lavo and the CrystalClear console, also Omnia and the new Vocco 8, this guy right here. multiple mic processor, so much more, just awesome. And also the folks at Axia and their Fusion console. Chris Tobin, thank you, and we'll see you next week, and we'll see you back live here in 2 weeks. Actually, we've got a heck of a surprise for you in 2 weeks. Larry Wilkins is going to be our guest. He's going to give us a lesson on, I believe, a lesson on live mixing. Larry runs the Alabama Broadcasters Association engineering education forums. Anyway, does a lot of that, and it's a very popular program. Larry's a retired engineer. He retired from Cumulus a few years ago, and he was their engineer of the year. So great guy. He's coming to Nashville, and I'm going to interview him live from the Piccadilly restaurant where we're going to have our SBE meeting right after we do the interview. So it's going to be cool. Check it out, and be sure you tune in 2 weeks. Tell your friends. Thanks a lot to Andrew Zarian at the GFQ Network for producing our show. We'll see you next week on This Week in Radio Tech. Bye-bye, everybody.